Welcome in. We are going to continue our discussion on matter. And in this video, our objectives will be to identify properties and changes as either physical or chemical. And we'll try to explain the law of conservation of mass. We'll measure and calculate so many properties this semester. Just like with matter in our previous video, it's useful to classify the different types of properties. Well, let's jump right in. Our physical properties are those that do not change the composition of your matter when you are displaying or measuring that property. Our example here, what is the color of our matter? Well, how do you measure that? One way to measure it is to look at it with your eyes. Does looking at something change the composition of that matter? No. What about boiling point? How do you measure the boiling point of a substance? Well, you do that by evaporating it and measuring the temperature that it's at as it's evaporating. So you can take a pot of water and heat it up on the stove until it starts to evaporate. Does this change the identity of our substance? Well, the answer is no. We're starting with water, which is H2O, and we're starting with it as a liquid. But when you evaporate it to measure the boiling point, well, we're not changing the identity. It's still H2O when it evaporates. Now it's just water up as a gas instead of a liquid, but the chemical structure has not changed at all. One more here, the density of our substances. As we remember, density is the mass divided by the volume. To measure the density, you measure the mass, probably just using a scale. To measure the volume of something, well, many ways, as you might have seen in class the other day. Measuring the volume of something, maybe using a ruler or a graduated cylinder, etc. Either way, neither of those measurements changes the identity of your material. You can measure the mass and the chemical structure is identical. You can measure the volume and the chemical structure is identical. Therefore, this has to be a physical property. The alternative is going to be a chemical property. Chemical properties do change the chemical structure of your material as you are displaying or measuring that property. Let's look at an example. Flammability. How do you test if something is flammable? Well, the easy answer is you try to light it on fire. You try to burn it. When you burn something, this does change the identity of the chemical structure. It changes maybe your gasoline molecule into other smaller, simpler molecules instead of that original gasoline. Sometimes it's hard to identify these chemical properties because we can't physically look at our atomic structures easily, but we'll still try to build up this intuition and think about when our processes are going to change the atomic chemical bonded structures. Here are some other examples with maybe some easier to recognize pictures than what I just drew. Here we have our water evaporating. H2O as our water starts as a liquid, turns into a gas. It is still water. That's why this is a physical property. Meanwhile, if you have rusting as your property of matter, rusting is this process where you start with some maybe pure metal and it will turn into some oxide form of that material. Here we have iron turning into iron oxide, turning into rust, which has a very different chemical structure. You can see these oxygen atoms are sneaking into that chemical structure, forming new chemical bonds with those iron atoms. We have some practice problems and examples here. I'll start with this second example, the tendency of automobile paint to fade over time. Here's our animation of this. If you've ever seen one of these kind of cozy coupe vehicles around, they usually don't look like this very bright yellow and red color anymore. Most of the ones that I've seen out in neighborhoods are very faded. And the reason why is we have these dye molecules inside of our paint or plastic, these dye molecules which break down over time. Our paint or dye molecules are breaking their chemical bonds to change their color. If that's the mechanism, our automobile paint fading is going to be a chemical property because it is based on our chemicals, our chemical molecules breaking their bonds and falling apart. Jumping to our last example, the low mass for a given volume of aluminum compared to our other metals. If you're trying to measure this property, we need to measure the mass, maybe using our scale, and measure our volume, maybe using a ruler. To measure these properties, we don't need to change the identity of our metal, so this has to be a physical property. We have two more practice problems on this slide. Pause the video, take a moment, try to write down some answers. Moving on, we can also describe the differences between physical and chemical changes. This is going to be analogous to our physical and chemical properties. But now, instead of thinking about a characteristic of matter, we're thinking about the process that something can undergo. It's almost like in languages thinking about an adjective compared to a verb. One is describing something, one is actually doing something. Regardless, our definitions are still the same. Physical changes do not change the identity of our substance, do not change any chemical bonds in our substance. Likewise, our chemical changes do break some chemical bonds, do form some chemical bonds. They are going to change the identity of our chemical structures. The way we like to denote this is by writing our chemical processes, our chemical reactions, as this form. Our starting materials turn into our final products, or we call our reactants our starting materials. Our products is what we end up with. This arrow shows that we have some process, some change happening. To actually decide if there's a physical or chemical change happening can be pretty difficult. To confirm that we have one or the other, you would have to do perhaps some pretty intense experiments. To look for a chemical change, there are some telltale signs that there might be a change. One is heat being exchanged, one is color being changed, one is maybe bubbles forming, things like that. But you would still want to do lots of experiments to prove to yourself that you do have a chemical reaction if you're doing this yourself in real life in the lab. For us in the classroom, it's not always as hard because we can see the animations or cartoons of our physical molecules, which allows us to more easily determine, oh, are these molecules changing or staying the same? For example, on the left, we have liquid butane sitting in our lighter. When you press down on the plunger here on your lighter, that butane is going to be ejected from a liquid into a gas. This change from a liquid to a gas is only a phase change. It is not a chemical change. Phase changes are going to be physical changes. We still have the exact same butane molecule. We've only changed it from a liquid to a gas. This has to be our physical change. On the other side of this slide, we have what happens when you turn this wheel and get a spark going. When you spark up this gaseous butane, it will burn, it will combust. And now we have butane turning into other products, turning into water and carbon dioxide. Here we can see our products are different than what we started with. We have burned or combusted that butane, and we have changed the identity of that chemical. Therefore, this has to be a chemical change. We've gone from butane into different chemical structures, water and carbon dioxide. And so this must be a chemical change. Once again, we have some examples and practice problems. We can start with this example, copper metal forming a blue solution when dropped into nitric acid. We have a hint here. We're starting with maybe coppery is a brown metal, turning it into a blue solution. That color change is a hint that we have a chemical change. To know for sure, you might have to do some experiments, but I'll tell you, we have copper as a metal turning into copper ions with a positive charge, which is going to be dissolved. We'll call that AQ. More about that in a few weeks. But this is going to be a different chemical structure with different properties. So therefore, this is a chemical change, chemical process. Our second example is a train flattening a penny on a railroad track. Our penny is, well, it's also mostly copper. Here we have our penny. Once it's been flattened, we have, well, still our penny. It's still made of copper. It's still all the same material. It's just a much flatter version. Are we changing the identity of that substance? Are we changing the chemical structure of that substance? The answer is no. So this must be a physical change. We still have the exact same chemical structure. All we've changed is the shape. We have 3 more practice questions on this slide. Take a minute, pause, and see if you can write down some good answers. All right, finally, our last goal for this video is to talk about conservation of mass. We talked about properties that we measure certain ways. We've talked about different processes we can do, chemical and physical processes. As it turns out, whatever chemical or physical process you do, you are not going to change the total amount of matter in the universe. Whenever you do a process, if you add up the mass of everything that you start with, After the process, you'll still have that same amount of mass. Matter is not created or destroyed even during these chemical reactions. This might not always seem true. If you're thinking about burning something, you're starting with maybe fuel in your lighter and it gets burnt and disappears. But it is true. You just have to be careful about capturing all of the products that are made and measuring the mass of those products. Here we're producing gases that tend to escape, but if you were able to carefully collect and capture and measure those products, you would find that, well, the total mass before is still equal to the total mass afterwards. Here is our overall process. Butane combines with oxygen to produce carbon dioxide and water. We have 266 grams of butane and oxygen. After going through our entire lighter, all of that butane might be gone, but it's still converted into the same total mass of things. They're just rearranged into a different form. Now they're in the form of carbon dioxide and water. All right, we've made it to the end of this video. By now, we should be able to identify properties and changes as either physical or chemical. And we've now talked about the law of conservation of mass. We'll get into the conservation of energy a little bit in the future, as well as the rest of these objectives. Well, there we go. Thanks so much for tuning in. Hope you all have a great day, and I will catch you next time.